Thanks for being with us. Welcome to another production of Can4 Empresaria Latin America. On this occasion, we have a video aimed at mid-level refrigeration technicians or personnel who are in charge of servicing equipment, such as cold rooms. Today we present temperature graduation in a cold room, which works with R422d refrigerant gas to achieve maximum efficiency. If you want to know this content, because the professional generation of cold catches your attention, stay with us, but before remember to subscribe to the channel. Let's start by saying that the capacity of a thin tube evaporator depends on three fundamental factors. 1. The temperature from the air, which comes from the cold room and will pass through the evaporator. 2. The evaporation temperature of the refrigerant, just before the entire liquid phase evaporates. 3. The superheat value at the outlet of the evaporator. The three factors mentioned above will allow us to make an evaluation of the team. In our case, we have the installation that we are showing on the screen, which is currently working with R422d refrigerant. Now, we are showing the table of thermodynamic properties of refrigerant R422d. On the left in the first column, we have the saturation temperature. In the next two columns, we have the bubble or liquid pressure, and then the vapor or spray pressure. If you are wondering why there are two types of pressures, this is because R422d gas has slippage. This sliding means that the temperature of R422d, in its transformation from liquid to vapor, or from vapor to liquid, does not remain constant. In an azeotropic mixture, such as R422d refrigerant, the change of state of the most volatile compounds occurs first. This causes the temperature to increase throughout the phase change, until complete evaporation occurs. The cold room is with the normal amount of products. The pressure indicated by the low manometer is currently 4.50 bar. This time our table is already the manometric pressure directly, which will facilitate the procedure. Verifying in the R422d table, with the pressure of the manometer, there is a saturated steam temperature of 4 degrees Celsius. This temperature is found in the vapor pressure column of the table, because the refrigerant at the outlet of the evaporator is found as saturated vapor. The thermostat is set by the user at 10 degrees Celsius. The air temperature, which comes from the cold room, and enters the evaporator, is currently 11 degrees Celsius. To carry out the evaluation of our installation, we are going to develop the following steps. Step 1. The difference between the air temperature, which will pass through the evaporator, and the dew point temperature of the refrigerant is calculated. This must be done just before reaching the desired temperature inside the cold room. Step 2. With the difference calculated in Step 1, the ideal superheat is calculated. Step 3. With the ideal superheat, we calculate the ideal temperature that the R422d refrigerant should have at the outlet of the evaporator. Step 4. Now we proceed to measure the temperature at the outlet of the evaporator. Step 5. Based on the ideal and measured temperature, the decision is made to adjust the valve spring or to open it. Let's go with Step 1. In this case, the difference is calculated between the saturated refrigerant R422 at 4 degrees C and the cold room air at 11 degrees C, for a difference of 7 degrees C. Let's go with Step 2. Now we calculate the ideal superheat, with the difference calculated in Step 1. For this we use the formula that we are showing on the screen. Using the formula, we must multiply 0.65 by 7 degrees Celsius from the difference calculated in Step 1. The result of the multiplication is 4.55 degrees C. Therefore, the ideal superheat of this installation is 4.55 degrees C. Now we go to Step 3 and calculate the ideal temperature at the outlet of the evaporator. This is calculated with the following formula. Ideal temperature is equal to the saturated steam temperature plus the ideal superheat. Now in step 4, we measure the temperature at this point. For this a suitable thermometer must be used. In this case the value of the measurement was 8 degrees Celsius.
Step 5.
In this case, 8.55 degrees Celsius is the ideal temperature, and 8 degrees Celsius is the temperature measured by the thermometer. When we compare the two temperature values, and they are both very close, say less than 1 degree apart, we can leave the system without readjustment. Now we are going to quickly analyze the temperatures present in the evaporator of this equipment, so that all the terms are very clear. With the pressure of the manometer, in this case 4.50 bar, we look for the inlet temperature of the refrigerant R422d, in a liquid state, to the evaporator. In this case looking in the liquid column, we find that the temperature is very close to zero. With the same pressure, we look for the outlet temperature of the saturated steam, which as we have seen has a value of 4 degrees Celsius. To find the average evaporator temperature, we look for the average temperature between these values, which results from adding them and dividing them by 2. The result is 2 degrees Celsius. After the refrigerant finishes boiling, its temperature begins to rise, reaching 8 degrees Celsius according to the measurement with the thermometer. The current superheating of the installation results from subtracting the outlet temperature of R422d, with its steam saturation temperature, in this case subtracting 8 degrees Celsius, minus 4 degrees Celsius, results in superheating of 4 degrees Celsius. The ideal overheating of this equipment, as calculated, should be 4.55 degrees Celsius. Why is the analysis we just conducted important? Mainly for 1, verifying the presence of non-zero superheat in the R422d allows us to ensure that there is no presence of liquid refrigerant in the compressor suction. 2. A high superheat increases the temperature and can modify the properties of the compressor oil. 3. High superheating can cause an increase in electrical consumption. 4. With overheating, we can know if the amount of cold that is needed is being produced. Thanks for joining us.